Hello, I'm Dokhyun Im. This is a presentation for midterm exam of the RFIC class. Our professor is Namyoung Kim. Okay, this is our content. I'm going to talk about the active and passive device of MMIC. Active MMIC device actively function like amplifying in MMIC. Transistor like MOSFET, HAMT, HBT, and BJT is mostly used as active device of MMIC. Performance of MMIC is depending on the material choice of the active device. For example, gallium arsenide MOSFET can increase the speed and the resistivity of the device due to its higher saturated electron drift velocity and lower field mobility. The passive MMIC device passively function like impedance matching, DC biasing, phase shifting, filtering in MMIC. Inductor, capacitor, resistor, and so on are mostly used as a passive MMIC device. For example, spiral inductor with the L bridge structure widely used as passive device of MMIC due to its high Q factor and inductance. This is an example of MMIC schematic diagram. As you can see, the picture, the active and passive devices are implanted on the same substrate. Okay, I'm going to talk about the gallium arsenide MOSFET. Yeah, this picture is showing gallium arsenide MOSFET structure. The MOSFET is using gallium arsenide as semi-insulating substrate. On the top of that, a thin n-type gallium arsenide form a channel. There are two metal layers on it to form omni contact at the source and drain. Also, one metal layer to form a Schottky contact at the gate. I'm going to talk about the advantage of using gallium arsenide MOSFET. High electron mobility. Next one, low capacitance levels and high input impedance. Negative temperature coefficient. Lack of oxide trap. Final one is high level of geometry control. Next one is about this advantage of using gallium arsenide MOSFET. There are two disadvantages. The first one is Schottky metal gate. Next one is mobility reduction by scattering. I'm going to talk about the purpose of using gallium arsenide MOSFET. The purpose is to enhance performance of device in RF communication. Gallium arsenide MOSFET is usually used as high-speed transistor in RF communication and in high-speed logic circuit due to the high electron mobility. Also, gallium arsenide MOSFET provide high frequency performance combined with low noise and high efficiency. I'm going to talk about the indium gallium phosphide HBT. As you can see the picture, the left one is HBT structure and right one is energy band diagram of HBT. HBT is a type of BJT which uses different semiconductor materials for the emitter and base region, creating a heterojunction. The HBT is used as active elements of power amplifiers in RF system. Next one is about the indium gallium phosphide HBT. As you can see the picture, this is a cross-section view of the INGAP HBT structure. The HBT is widely used in many communication circuits due to the low price and high power, high efficiency of power density and linear characteristic compared to other active elements like MOSFET and HAMT. The HBT is also suitable for design of power amplifier due to its similar grid structure to gallium arsenide substrate and long lifespan and high current density and stable dumber properties. But the performance of the amplifier may be degraded by current collapse and dumber runaway made by high power density and voltage characteristics. So the design should be considered the change in the performance of the amplifier due to the temperature changes. Okay, next presenter will make the last of the presentation. Thank you.
RNA amplifies the weak RF signal transmitted from the TX. RNA is normally placed at the first stage of RF receiver because it promotes the low noise performance of receiver. Input 50 ohm matching is also important due to matching with the antenna or RF filter. Each like calculating noise usually express noise figure in dB method. The noise of the system is determined by the noise and gain of each block, and it can be seen that the first block has the greatest effect. It is a differential LNA circuit designed using ADAS2. It is usually aimed at NF specifications less than 3 dB and must meet other specifications such as gain linearity. The Smith chart is a chart created for convenient impedance matching of the transmission line. The diameter of the circle starting from the right means the real part, and the curve of the shape spreading from the right end means the imaginary part. Through this, it is possible to express the impedance value of the load in a single point. Shunt inductor for matching moves the impedance in this direction. A series of capacitors for matching moves in this direction, used to match load and impedance in this way. Amplifiers that amplify signals are often used, especially in radio communication, because they handle small signals. The purpose of the amplifier depends on whether it is transmitter or receiver. At the transmitter, the key is how much power to amplify the signal to desired point. Since the electromagnetic wave can reach the desired point only when the antenna emits the signal at the proper maximum power. The amplifier used for this is called the power amplifier. A mixer is a nonlinear element that converts frequencies. The filter is required because the frequencies up-down conversion and harmonic occurs. Linearity is an important indicator because the frequency is converted and the signal is produced. It is a conversion that transforms into high frequency and makes it available in the wireless transceiver system. Each down conversion that transforms the received high frequency signal back into a Kurz wave that we can use. That is, we raise the frequency for signal transmission and we lower it back to the frequency band we use when we are done. BJT consists of emitter, base, and collector, and is classified as NPN and PNP. The order of high doping concentrations is emitter, base, collector, and the width of the base is very small. There are 4 modes available depending on how voltage is applied at each single end, and 3 of them are frequently used. Active mode used BJT as an amplifier by hanging forward bias between emitter and base. reverse bias between base and corrector. The other two mode allows for the operations and switches. Thank you for the presentation.